In last two lectures, we proved the Helmholtz theorem. The other way to interpret the Helmholtz theorem is the divergence and curl of a vector provide enough information to determine the vector uniquely when the vector goes to 0 at infinity. To say that confidently, we are going to prove the uniqueness of the vector C. Let's consider two vectors C1 and C2 has similar divergence and curl. Now define another vector W equal to C2 minus C1. So the divergence of W will be zero, and similarly the curl of W is also 0. So Green's first identity states, considering phi equal to psi equal to W, where W is any Cartesian component of vector W, like Wx, Wy, Wz. The theorem can be written Remember, the C of R was at order of R to the power minus 1 plus epsilon, where epsilon was greater than 0. So W of R has to be also at order of R to the power minus 1 plus psi. So gradient W should be at order of R to the power minus 1 plus psi minus 1. So W gradient W has to be order of R to the power minus 1 plus epsilon minus 1 minus 1 plus epsilon. So finally r to the power minus 3 minus 2 epsilon naught. As the surface ds located at infinity, if we take the integral all over the space, so it is obvious that w multiplied by gradient of w has to be 0 at infinity. So as we have seen that curl of w is equal to 0, so curl of w must be 0. So gradient of divergence of w minus Laplacian of w is equal to 0. So divergence of w is also 0. So it turns out Laplacian of w is 0. So the any Cartesian component of w is also 0. So incorporating the results in Green's first identity, we get a volume integral of this quantity is 0. The square of modulus of gradient of w is always positive, so the only way for the integrals to be 0 is the gradient of w is 0. So w is constant. As the condition was c will be 0 at infinity, so w is also 0 to infinity, so the constant becomes 0. Then the vector w is also 0, so c2 minus c1 is 0, so c2 of r equal to c1 at r. Now we can say that if we know the divergence and curl of a vector and the vector goes to 0 at infinity, the vector can be determined uniquely from this information.